Hello, Year 9. Welcome to a new topic on chemical analysis. Today we'll be looking at a new topic on pure substances and mixtures. So by the end of this lesson, you should know how to use melting point data to distinguish pure from impure substances and how to identify examples of useful mixtures called formulations given appropriate information. Right, a quick recap. What is the difference between an element, a compound, and a mixture? Use particle diagrams to help with your explanation. So you can pause the video now and try to work out the difference between these three different types of substances. Right. An element is a substance that cannot be broken down into any other substance. Every element is made up of its own type of atom. So for instance, if you look on the periodic table, you can find different types of elements on there. They are all pure substances made up of its own type of atom. So when you want to draw the diagram of an element, like how it's shown on this slide over here, so it should contain only its own type of atom on your diagram. A compound is a substance that contains atoms of two or more different elements, and those atoms are chemically joined together. So if you want to draw a diagram of a compound, you can draw H2O. H2O, which is water, is a compound. So make sure you have two or more different elements on there. And lastly, a mixture contains different substances that are not chemically joined together. So that is the diagram that represents a mixture. Pure substances. What everyday meaning does this phrase have? And is the everyday meaning different to the chemical meaning? So pause the video and think about the answers for these two questions. So everyday meaning for pure substances would be when nothing has been added to a substance, so it is in its natural state. For example, milk or beeswax. And is the everyday meaning different to the chemical meaning? So pure substances means something that only contains one compound or element throughout. So for example, H2O is a compound. So if you have a glass of water, so you only have that particular H2O compound in that glass of water. If you mix that with the orange juice, then it no longer contains one type of compound. So you will have more than one in that glass. An element, it can be oxygen, nitrogen, hydrogen. These are the types of elements that can be classified as pure substances because it only has that particular type of atoms in that molecule. Now, let's look at the meaning of pure in more detail. So what does pure means when we are referring to pure substances? So the word pure, for example, pure orange juice would mean that it is only orange juice. But if you were a chemist, you would certainly not consider it pure because inside orange juice, you will have other different types of ingredients as well, like preservatives, food colorings. So when you have these different types of ingredients in orange juice, they are not classified as pure substances anymore. Pure in advertising might mean nothing has been added to it or that it is fresh. So scientifically, the correct definition for pure substance is a pure substance is one that is made up of just one substance. That substance can be either an element or a compound. Can you pause the video now and write down the definition of pure substance in your book, please? Alright guys, So for your task number 1, can you draw the table that contains different types of water with different boiling points and try to answer the 2 questions right below the table. So for example, question number 1, it asks you to explain what is the difference between these samples of water. And question number 2, what could have happened to cause this difference? So pause the video now and try to work on task number 1. Right, so the answers for your questions are listed on this slide over here. So for question number 1, what is the difference between these samples of water? So you can obviously see that all these 3 different types of water have different boiling points. So pure substances always melt and boiled at certain fixed temperatures. The melting point of pure water is 0 degrees Celsius and the boiling point is 100 degrees Celsius. So by looking at this data, so obviously water type A, B and C, they are not pure because they have higher boiling point than a pure water. So for example, water type A has got 100.8 degrees Celsius boiling point, B 100.1 and C is 102.5 degrees Celsius. So that means impure compounds have a range of melting points and boiling points, as the different substances that they contain melt or boil at different temperatures. So obviously the differences between all these 3 samples of water, they are not pure substances. Right, so for question number 2, what could have happened to cause this difference? So definitely it's going to be the presence of impurity. So it can be anything. Maybe they have salt in a pure water or sugar particles in a pure water that can affect the melting and the boiling point of pure water. So the presence of impurity usually lowers the melting point or raises the boiling point. So in this case, you can see the presence of impurities, which can be anything that has increased or raises the boiling point for water type A, B, and C. All right, year 9. So on this slide, I want you to identify which of these graphs shows an impure substance and why. So look at these 2 different types of graphs carefully and identify the one that is an impure substance. And you can even write down some sentence to explain the reason for that. So once you have done that, you can check your answer on the following slide. Right, so graph B is the one that represents the impure substance. This is because this sample does not have a definite melting point and ranges between 70 to 80 degrees Celsius. This shows it is impure. Whereas with graph A, this sample has a sharp melting point of 70 degrees Celsius. This shows it is pure. Right, now we are moving on to task number 2. So for task number 2, you need to describe and explain the graph. So what you need to do is you need to draw the graph in your book and then describe the pattern of the graph and explain the graph. So pause the video now and you can start working on this task. Right, to describe, from 0 to 4 minutes, there is a steady increase in temperature from 0 to 30 degrees Celsius. After 4 minutes to 11 minutes, the temperature continues to increase, but at an unsteady rate, which fluctuates slightly. After 11 minutes, the temperature continues to increase at a steady rate. So the first 3 sentences describes the pattern of the graph. And then to explain the graph, this is because from 0 to 4 minutes, the substance is increasing in temperature, but not changing state. After 4 minutes, the substance is using the thermal energy to weaken the bonds between particles and change state. Because the substance is impure, lots of different bonds are present which require different amounts of energy to break. Therefore, the temperature increase fluctuates. After 11 minutes, the substance has changed state. So the following four sentences explained the graph. So the first three sentences above describes the pattern of the graph, and the following four sentences explain the graph. So can you check your answers against these answers on the slide and mark your work accordingly, please. Right, so now let's look at the key points to summarize what we have learned so far. So point number 1, a pure substance contains only one substance, so melts or boils all at the same time. Point number 2, an impure substance is a mixture of different elements or compounds, so the atoms melt or boiled all at different times, and this can be represented by using graph B. And point number 3, a pure substance melts and boils at a specific temperature. Again, you can represent this by using graph A. Now we are going to look at the meaning of mixtures and formulations. Formulations are mixtures that have been designed as a useful product. Examples: baby formula, medicines, paints, makeup, tomato ketchup, alloys, and fertilizers. Why it is important the formulation of the mixture stays consistent for above examples. So can you pause the video now and try to work out the answer for this question? Right, a formulation is a mixture that has been designed to do something useful. It is formed by mixing together several different substances in carefully measured quantities to ensure the product has the required properties. So going back to the examples like baby formula, medicines, paints, makeup, tomato ketchup, alloys, and fertilizers, all these products will have its own formulations, and all the mixtures inside this formulation needs to stay consistent in order for the product to have the required properties. Medicines have an active ingredient but need to have other things mixed in it too, so that it can easily be taken. We will look at this in more detail on the next slide. This is what we mean by formulation. Formulations are also used in foods to ensure they taste the same each time, a bit like a recipe. This is an example of paracetamol, the label of a paracetamol tablet. What is the active and inactive ingredients in paracetamol? And what are their roles? Can you pause the video now and try to work on these two questions? Right, the active ingredient in paracetamol is paracetamol 500 milligram. And the function of paracetamol 500 milligram is to relieve pain. And the inactive ingredients are pre-gelatinized starch, povidone, magnesium stearate, and sodium starch glycolate. So for example, pre-gelatinized starch, the function is it can easily dissolve the tablet in cold water. Povidone is there to act as a tablet binder. Magnesium stearate is to prevent the individual capsule from sticking to each other. And sodium starch glycolate is there to absorb water rapidly. And they are also used as suspending agent and also as a gelling agent. Okay, now let's do a quick progress check on what we have learned so far about mixtures and formulations. So for question number 1, what is an active ingredient in formula? Question number 2, why might tablets contain an inactive ingredient? Question number 3, why do tins of the same color paint need to have the same ingredients each time? And the last question, why are alloys classed as a formulation? So you can pause the video now and try to answer all these questions in your book. And then we can check the answers on the next slide. Right, so for question number 1, what is an active ingredient in formula? The answer is the ingredient that delivers the effect. For example, the medicine product. Question number 2, why might tablets contain an inactive ingredients? Preservatives to change the taste, to allow the body to absorb the medicine more effectively, cannot sell the small amount of active ingredients on its own, has a carrier or increased size, filler materials. For example, talc, lactose, and starch. Question number 3, why do tins of the same color paint need to have the same ingredients or formulation each time? This is because otherwise the color would be different. Right, the last question, why are alloys classified as a formulation? This is because they are made from different metals or chemicals in a certain ratio to change the properties to suit their use. So for instance, brass is mainly used as door handles and fittings. So brass is made from copper and zinc. Qualities are very important when it comes to manufacturing products. In a formulation, the qualities must be exact each time. This ensures the properties are correct. In medicines, this is particularly important. Such things have to go through a process called quality control or quality assurance. These are laboratory tests to ensure products are to the correct standard. On this slide, I want you to try to answer the following questions in your exercise book. Question number 1, why does the formulation of metals used to make electrical wiring need to be exact? Question number 2, why does the formulation of a medications need to be controlled every time it is made? And question number 3, which medicines would be rejected following quality control and why? So for question number 3, I want you to look at the table. You have different types of medicines, medicine A, B, C, D, E, and F, with a different percentage of active ingredients, different percentage of filler, and also different percentage of lubricant. So analyze the table and which one do you think would be rejected following quality control and why do you think this has happened? So pause the video and try to answer the following questions in your book. Right, so you can start to mark your work. For question number 1, why does the formulation of metals used to make electrical wiring need to be exact? So the answer is so that the conductivity doesn't change. For question number 2, why does the formulation of a medications need to be controlled every time it is made? The answer is so that it works correctly and is safe. And the answer for question number 3 is C and E. So if you look at your result table, the percentage of filler for C and E is out of the pattern. It doesn't fit the pattern. So if you see for the rest of the medicine is 69.27, apart from C and D, it shows 69.37 and 69.25. And the percentage for lubricant for C is also doesn't fit the pattern, which is 24.38, where it meant to be 24.48. Right, year 9. So now we are going to use some maths skills in this topic. Okay, so if you look at question number 1, a tablet is made up of 0.050 grams of aspirin added to 0.79 grams of starch and 0.11 gram of talc. So calculate the percentage of the active ingredient. Show your working. So for question number 1, you need to identify the active ingredient first. It is a tablet. And then work out the percentage of the active ingredient. So think about the formula and use the formula to work out the percentage. For question number 2, a second tablet is made up of 0.065 gram paracetamol added to 1.1 grams starch, 0.01 gram Knole wax, and 0.13 gram talc. So you need to calculate the percentage overall of the inactive ingredients. So for question number 2, you need to identify the inactive ingredients first and then use the right formula to calculate the percentage of the inactive ingredients. Again, you can show your working. For question number 3, which is based on the table, food B, if you see the middle column, that's food B. Food B has 7 gram more starch than food A, 3 grams less sugar than food C, and equal amounts of saturated and unsaturated fat. So what you need to do is you need to fill out the table for food B based on the information provided on the table and also the statement given on there. So you can pause the video now and try to work out the answers for the following questions, and then you can double check your work on the next slide. Right, so the answer for question number 1 would be total mass is 0.95 gram. That is the active ingredient, equals to 0.050 grams. Divide that by total mass and times by 100. You will get 5.2%. So for question number 1, it asks you to calculate the percentage of active ingredients. So based on the statement that's been given, the active ingredient will be aspirin, which is 0.050 grams. And you divide that by the total mass. So you need to work out all the total grams, ingredients in that tablet. So you need to add 0.050 grams of aspirin. You add with 0.79 grams of starch and add 0.11 grams of talc. So by adding all them together, you will get the total mass. So you have 0.050, which is the active ingredient. You divide that by the total mass and you times that by 100, you should get 5.2%. For question number 2, it asks you to calculate the percentage overall of the inactive ingredients. So you need to look at the inactive ingredients. So what are the inactive ingredients? So it's going to be starch, which is 1.1 gram, Knole wax, which is 0.01 grams, and talc, which is 0.13 grams. So again, you have to work out the total mass first, which is 1.3. So to work out the total mass, you add all them up together, 0.065, you plus with 1.1 grams, plus 0.01 grams, and then plus with 0.13 grams. So you should get 1.3 grams. That is the total mass. So after that, you identify the total of inactive ingredients. That means you need to add all the amount for inactive ingredients, which are 1.1 grams of starch you plus that with 0.01 grams of carnauba wax and 0.13 grams of talc. So you should get 1.24 grams. So to work out the percentage, 1.24, you divide that by the total mass, which is 1.3. You times that by 100, you should get 95.38%. And then for the answers for question number 3, you need to fill out the table for food B. So food B has 7 grams more starch than food A. So if you look at food A, the starch is 40. So 7 plus 40, you should get 47. And for sugar, it has 3 grams less sugar than food C. So if you look at food C, the sugar level for food C is 25. So 25, you minus 3, you should get 22. And the unsaturated and saturated fats, it remains the same, which is 15.1 and 15.1. Okay, so that's the answer for the table for food B. Right, on this slide, I've listed down some key points to summarize today's lesson. So key point number 1, pure substances can be compounds or elements, but they contain only one substance. An impure substance is a mixture of 2 or more different elements or compounds. Point number 2, pure elements and compounds melt and boiled at specific temperatures, and these fixed points can be used to identify them. Melting point and boiling point data can be used to distinguish pure substances, for example, specific fixed points, from mixtures that melts or boils over a range of temperatures. And the last point is formulations are useful mixtures made up in definite proportions, designed to give a product the best properties possible to carry out its function. Right. So these are some useful links that you can use for today's lesson. So BBC Bite Size, you can find lots of topics on chemical analysis and also on free science lessons. I find these links are really very useful to help to understand the topic even better. So please feel free to use the links, and you can even take down some notes if you wish to. Right, that's it for today's lesson. Thank you very much for joining me today. I'll see you next time.